Okay, so now that hopefully you feel like you can find an asymptote, and hopefully even better, you can find it and tell me if it's positive or negative infinity. It's like a, kind of a dance, I guess. No? Bad dance? Yeah, terrible dance. Never mind. Bad idea. But this time we're going to take a look at building up those ideas of what it's like to work with infinity. So let's just say you have $1 billion. No, let's say you have $1 trillion, and somebody flips you a nickel. Would you bend over to pick that up?
Yes. Yeah.
Well, I guess if you made $1 trillion in the first place, you're probably pretty good with money. But what do you think? I mean, honestly, okay, never mind then. Every cent counts. Okay, but the point I was hoping to make was that in the grand scheme of $1 trillion, a nickel is like, it's not worth your time to pick it up because it would cost $5 to stop and pick it up since your time is so valuable. But anyway, the point is, when you have infinity and you add some number to it, it's still just going to be infinity. It's not significant. Okay. Same thing as if we had infinity and we took away some number. Well, that won't change it. One thing that could happen, though, is if we had some number and we take away infinity, then we'd have a negative infinity this time. So then that's nice math. It's just the answer tends to just be infinity. I know it's infinity, right? Okay. So if you're a real hardcore nerd, if somebody said, hopefully one day you're happily married and your partner says to you, I love you infinity plus 1, and you can just say, well, I love you infinity because it's the same thing. And if they stick around, then you found true love. What's that?
Did that actually happen?
No. Okay, so multiplication with infinity. If you have, so of course, one thing we should note here, we haven't looked at this yet, but it's interesting when you multiply 0 by infinity. I'm not going to expect you to deal with that now. But 0 times infinity is another interesting limit. So when I say it here, I'm saying when the limit is not a 0, limit times infinity, well, yay, it's still infinity. Okay? If the limit was negative, it's possible for it to change it to negative infinity. But again, it's still going to be that on its way to infinity. For the quotient rule, can someone put their thinking cap on and tell me what they think happens? Yeah, that's right. How did you know that, Dylan?
I read the book.
You read ahead in the book. Good answer. Okay. Well, it's going to be 0 because the bottom is getting so large that it's just decimating the top. The top is just gone. So think about if you had a pizza and you only had to share it with one person. Now all of a sudden, you have to share it with every student at Johnson Heights. Like, how much does your slice of pizza change to? Right now, imagine that you went all the way to every person in the world. You really wouldn't even, you'd get like a crumb, right? It'd be so small. Then after you go to infinity, it would be 0. Now, the thing about 0, even if I divide by negative infinity, it's still going to become 0. It just means it's going to approach from the negative numbers. So in a picture, what would it look like? Well, if you were to graph this one here, if I'm taking my slice of pizza and I'm dividing it by -5 and -10 and -20, -100, -1,000, it's still approaching 0. It's just doing it from the bottom side. If I'm doing it from the positive numbers, it's doing it like this. Okay? So either way, it still goes to 0. Infinity divided by a number? Sure, we can throw that in there. What do you think? What would infinity divided by a number be? Okay, be more careful. You're correct 50% of the time. Positives and negatives would matter here, right? Same as the multiplication rules. If you divided it by a positive, it's still infinity. If you divided it by negative, it'd be negative infinity. Okay. So it might be harder for you to see on your sheet there, but this is, oh no, it turned out, look at that. First time in this slide, actually. So I want you to talk about the limit as x goes to 0 for the left and right sides. Okay, use what you know. See if you can figure out, these are the, using obviously the sum rule. This is the product rule. And this is the quotient rule. So see if you can manipulate those infinite limit laws, and hopefully we can all come up with an answer together. Okay, so I'm going to walk you through them if you haven't already gotten there. As I approach 0, what does x to the 5th become? Oh, good. We haven't forgotten the easy ones. You can just substitute that. There are no problems there. But what happens when I go to the left side? I'm approaching 0. 1 divided by 0 should give me an asymptote. The question is, will it be positive infinity or negative infinity?
Positive.
How do you know it's positive?
Because x squared is always positive.
Yeah, x squared is always positive. This number here, it's always greater than or equal to 0, which means this is going to have positive infinity for its limits. So it's going to be 0 plus infinity, which is still infinity. Okay? Same thing on this side for the same reasons. That goes to 0. That will go to positive infinity. So 0 plus infinity is infinity. Okay. Now in the next example, I have to think a little bit harder here. Cosine of 0, what's that going to be? Cosine 0. Yeah, it's 1. So that, there's no problems. It's a 1. Now, if I approach, it's hard to see here. That's supposed to be a left side. Okay. If I approach from the left, will 1 over x go to positive infinity or negative infinity? Yeah, negative, because the left side of 0 are negative numbers. So that means this is going to be negative infinity times 1, which still is negative infinity. Okay? On this side, that cosine of x would be 1, just like we talked about previously. If I go from the right side, it's going to be positive infinity. That's right, because numbers to the right of 0 are positive. So it was infinity times 1 is still infinity. Okay. The last example, careful. The last example is, well, trig always seems to give us some struggles. So let's think about this. Cotangent pi x, what I'm really looking at, you should be thinking about this in your head as the cosine of pi x over the sine of pi x. Now I'm going to be honest, I'm going to do a number line here. I'm not going to take the chance of making a careless mistake. Why not? Let's do 1 for cosine, 1 for sine, and what I'm interested in is near the value 1. Okay? Now the easiest way I can show you what happens is to think of the graph. Okay, here's the graph of cosine. And the graph at 1. So at 1, what I'm talking about here is the cosine of pi. So that's right here on the picture. So values which are to the left are still negative. Values to the right are also negative. So in this picture, it's negative right close on both sides of 1. For the sine graph, this time my picture's different. It goes like this. And again, if I put it in at x equals 1, I'm talking about the sine of pi here. So values which are to the left, those are negative. Sorry, those are positive. And values to the right, those are negatives. They're the values like right here. So now I can see the combination. As I approach from the left side, it's going to be a negative. As I approach from the right side, it's going to be a positive. So this limit will be 1 squared plus 1 divided by, on the left side we said it was going to be negative, so negative infinity. 2 over negative infinity, that's going to be 0. Sorry? Okay. In this example, it's going to be 1 squared plus 1. I'm approaching, it's the right-hand side here. It's hard to see that. But right-hand side is this piece. So it's positive infinity, which means I'm still approaching 0. Okay? One comes in from the bottom, the other comes in from the top. Okay, so that will conclude our discussion on infinite limits. I'll get you the homework.